So we're continuing with chapter 3, the second session, and I got detained there because I got a phone call, but this is in your chemistry book. And we're to the point of naming ionic compounds. And we saw here the name of an ionic compound consists of the name of the cation followed by the anion, right? But putting these together, you're going to need to know if it's a copper 1 or a copper 2 or what to put in here, what the charge of the copper. This means the charge, and we went over in the last section about that. So the name of you put those two, the name of the cation is always first, and then the name of the anion is always second there. So whether the compound is binary, made up of two elements, or composed of polyatomic atoms, the procedure is the same. For example, baking soda. We have baking soda consists of equal numbers of sodium cations and bicarbonate ions. So here you have sodium bicarbonate, right? And the following are the examples. So basically sodium bicarbonate would go together. You'd put sodium first, which is Na, and then the bicarbonate. So here's some other sodium hydroxide. Remember, hydroxide is in your table, it's negative. And sodium is a negative, positive one, and hydroxide is a negative one. Calcium carbonate. So the calcium is a positive 2, and carbonate is a negative 2, and they hook together. Potassium cyanide. Base of potassium is K, and cyanide there. So as they hook together there, they're going to be equal. Copper 1 means it has one charge, positive charge, and chloride has a negative 1 charge, so they hook together. Ammonium nitrate, so we have ammonium nitrate hooking together, and magnesium hydroxide. You know, magnesium has a positive 2, and hydroxide has basically a negative 1, so you're going to need 2 of those. So you have to put it in parentheses to say this whole poly thing goes together, and there's 2 of them. So this is going to be a negative 2, and this will be a positive 2, so they hook together. So I hope you kind of got that. It's a little bit, can be a little bit complicated, but as you go, you'll find it becomes pretty easy, kind of like a puzzle. So when naming the ionic compounds containing an element that can exist in more than one catatonic form, the full name of the ion, according to the stock, must be used, is what they're saying here. So let's go up here. So if you have, down here it says, if you have copper sulfate and copper 2 sulfate, they cannot be both copper sulfate. So you have to tell which copper sulfate it is. Therefore, let's go up the top here. Let's see. Oops, I'm sorry. So the different compounds should have different names. So copper sulfate is copper 2, and then we have copper 1. So you have to put down whether it's copper 1 or copper 2, because they'll be totally different ions. One has 1 negative charge and one has 2 negative charge. So you have to put these Roman numerals in there, and that's what we're going to learn how to do. So correctly naming such compounds requires knowing the charge of the cation. So you have to know the charge can be determined by using the charge of the anion, and the rule that the charges of ions in an ionic compound must balance. You always have to have the same number of positive cations as you do the same number of negative anions. They have to balance out. For example, sulfate always has a charge of negative 2 right here, and has only 1 copper to balance, so it's a negative 2 of sulfate. Therefore, the charge of the copper ion must be 2. So we can figure out the charge sometimes by which ion is combining with it. So, and that's what we're going to need to know. So I'm going to do some examples of that. So we're going to take some examples of that so we know. So let's see. Same thing with magnesium. So you have to know. So here, this is the example here. Let's zoom in here. So we're going to name the following ionic compounds. Okay. We need to know if there's many forms of lead. At least we know a couple forms of lead. So we need to know if it's lead Pb2 or Pb1 or Pb3. So lead we need to know. So it says naming these compounds, and let's look at the example. It says, since lead has 2 catonic forms, which must be specified what the cation is. The single lead ion must be 2 negative. the charge of the single chromite ion and therefore must have a positive charge. So here we go. So lead, so this charge, if we look it up in there, we find out what this CrO4 has, and we find out that COR4 has a positive or a negative 2, which means the lead has to have positive 2, so lead has to be 2. So the lead is 2 chromite. So you're going to say this you're going to say that this is lead 2 chromate. You get these from the chart over there, okay? You could look up in that chart on the other page that I just showed you. So let's go on this FeO. So what about FeO? Fe means iron, so we know it's going to do with iron, and oxygen is O. So iron has 2 ionic forms, but oxygen ion does not. So we know that oxygen's always going to be +2, right? Since 1 ion of each is present, oxygen is going to be I say +2, -2. -2. The ion must balance by being +2. So the iron has to be positive. The iron has to be, since this is O, it has to be -2. The iron has to be +2. Thus, iron FeO is going to be iron 2, right? It has to be 2 to balance out with the 2 of oxygen, -2 of oxygen. Okay, so you got that? It's not too hard. You can look back to your tables too. The next one is another iron Fe2 with O3. Okay, we have iron oxygen again. So this time we're going to have to look and see, okay, we know oxygen is always going to be -2, but if you take -2 and have 3 of them, that means you're going to have a -6. So the iron has to be a +6. Well, to make it +6 there, we have to basically take which one, so we have to take which one to make it 6. Well, if we have iron 3 times 2 equals 6, or is it going to be iron 2 times 2 equals 4? So it has to be iron 3. So since 1 ion is present and oxygen is -2, the ion must balance by being a +2. Thus, iron is going to be iron 2 oxide. So if you look at this, if it's iron 2, it's going to be, or basically here, if it's going to look, negate what I was saying there. I was looking back at this equation. There are 3 oxide ions. So you got the 3 oxide ions. This one here, F2O3. That's what there are 3 oxide ions for a total of, and so basically you're going to say the least common multiple of those, right? So basically, if each ion is 3, 2 of them will balance. So basically, the iron in the 3 form is going to be iron 3. Basically saying iron 3 would be 3 positive. 3 times 2 is 6, and then 3 times 2 is 6. So then it will balance out. So iron 2O3 is iron 3 oxide. You got that? Okay. I went back and started doing this problem instead of this problem. But anyway, we're going to go to zinc, and zinc has only 1 form. We simply name the ions of acetate is negative. So basically, zinc is zinc and acetate is acetate. So if we have a 3 of acetate, we know that acetate is a -1, and you have, not 3, but 2 of them. So here we have 2, so this is going to be 2 negatives, so we know that zinc is going to be 2 positives. So because zinc has only 1 form, we simply name the ions. This is acetate and this is zinc, so you call it zinc acetate. There's no Roman numerals in this one. So you have that? Okay. Now let's go on to finding the empirical formulas of ionic compounds. That's the simplest formula, right? So the name of an ionic compound does not tell you how many ions are in the formula unit of the compound. So we must determine the ratios. So the cations and ions are oppositely charged. So the charges can cancel each other out, and that results in an equal number of positive and negative charges. So basically saying that an empirical formula is always the simplest ratio of ions that results in equal number of positive and negative charges. For example, the compound calcium chloride cannot exist of equal numbers of calcium and chloride because calcium is 2 positive ions and chloride is 1. So because their charges would not balance, then they have to balance. Instead, we have to balance them out and have that empirical formula. So we have to have the formula being calcium is just 1 and chloride has to have 2. So there has to be 2 of those to 2 of those. So the cation is always written first. So, and going on, it says polyatomic ions must be enclosed in parentheses if the formula unit includes more than one. You have to keep it in parentheses. So the formula of calcium hydroxide consists of calcium is 2 ions and 2 hydroxide is OH. We're going to have to put the OH in parentheses. So then you write the empirical formula is calcium, and you need 2 of these, right? So you put OH in parentheses and put a 2 by it. Not so hard. Parentheses are not used if there's only one of the ion present. So basically if you had like, this is sodium hydroxide, sodium and hydroxide, well there's just one of those, so you don't have to put a parentheses because you don't have a little number by it. So that's kind of important to know. So example, let's look at these examples. Hope I can get you can just kind of read it, but I want to explain it to you. Write the formulas of the following ionic compounds. So we have calcium bromide, right? So let's see here. Calcium bromide to balance this. Calcium bromide, they want you to write the formula. So what's the formula? Well, we know calcium is Ca, and if you look back at our chart, calcium always has a positive 2. Bromide is Br, and so it always has a negative 2. So the calcium ion has a 2 and the bromide has a negative 1. To balance the charges, it must be 1:2 ratio, so you have to have the formula calcium right there and bromide with a 2, and that balances it out. A tin, okay, this is tin oxide. Well, tin has the charge of +4 because there's a 4 there, right, in Roman numerals. So there's 4, and oxide ion has a -2. So basically, if you have 4 of these and 2 of these, you're going to need 2 of these, right? If you have 4 charges here and you have 2 charges here, you're going to need 2 oxygens or 2 oxides. So 2 oxide ions are needed to balance this, and so it would be tin is Sn and then O2, so SnO2. Okay, let's go on to the aluminum sulfate. So aluminum has the charge of 3, and the sulfate, which is SO4, and that's on your chart, has a -2. So we have a 3 and a 2. This is another one where we're going to have to look and get the least common multiple of them. Because 2 is not a factor of 3, no whole number can balance it. So you have to, the smallest number has to be 2 and 3, so least common multiple, as we said before. So here we have, if we have, so we're going to have 3 and 2. So we're going to look down here, and so what we need to do, the empirical formula has to be aluminum. So we're going to take 2 aluminums, which has a 3 charge, so 2 times 3 is 6. And then we're going to take 3 of these so we can balance this out, because we need 6 of these and 6 of these. Well, there's only a 2 charge, negative charge here, so we're going to need 3 of those. So we have aluminum, A2, and then sulfate, we need 3 of those. So this is so we're going to have to make sure. So aluminum has 2, has 3, so 3 positive plus 2 is 6, and then sulfate has 2 negatives, and so 2 times 3 is 6, so they balance out. Okay, so this is balancing. So we're going to we're going to go over your section review here, because you're going to have some of these on the test now. This is kind of gets a little bit complicated here, but not too bad. So let's look at so we're going to have the review here. So name the following ionic compounds. We're just naming them. So this is here, Na means sodium, and NO2 is going to be nitrate. So it's going to be sodium nitrite, right? Because we look at this, we look at that table, and this is a nitrate. So sodium nitrite, which is +1 and -1. So that goes together. So let's look at the table for this one. Let me zoom in a little bit more on there. Can you see them? So Ag is silver, right? So we have Ag is silver, and of course we have NO3, which is nitrate. So if you looked on your table, NO3 is nitrate. So you'll have silver nitrate for that one. This one here, copper, Cu is copper, and that's chlorine there. So as for we can't say copper chlorine, we'd say copper chloride. Chloride, so it'd be IDE. So this one is Pb is lead. So we have lead, and we know that SO4, if you look back there in that table, is sulfate. So it'd be lead sulfate. This one here, zinc. So we have zinc here. We know that this one's going to be zinc, and then this is going to be phosphate. So it'd be zinc phosphate. This here is going to be NH4. What's NH4? If you look back on your table, NH4. Let's look back on that table. Well, this one here is C2H3O4. This is a hard one, so let's look back on that table. Sorry. There we go. Let's look back on our table. Okay, you see these here? Hydrogen, phosphate, we got these all here. So look back and we'll just find out which one this is. I kind of forgot. I'll see. It's sorry. NH4, C2H3. Okay, I have to remember what they were. NH4.